Welcome back to the chapter Coordinate Geometry for Standard 10. This is part 2. Find the equation of the perpendicular bisector of AB, where A and B are the points 3 and 6 and minus 3, 4 respectively. Now we have to find the point of intersection with the x-axis and with the y-axis. So here the concept that we are going to use is let AB be the line, let this be the line, and A and B are the points on the line with these coordinates. And now we have to find a point on the perpendicular bisector. So this line L is a perpendicular bisector of the line segment AB. The perpendicular bisector means this line divides the line into two equal parts, and also this will be 90 degrees. That is called a perpendicular bisector. So we have to find the equation of this line. So if we find the equation of this line, any point on this line will satisfy the equation. So now if you consider a point P on this line and consider these two triangles, then we can say triangle POA and POB are congruent because of these are equal. This is 90 and this is common. So SAS, we can say the two triangles are equal. Then PA is equal to PB. So the distance from the point on the perpendicular bisector to the end points are always equal. So PA is equal to PB. So that is what now we are going to use. So we will find the let PB XY. Now if you find PA equal to PB, then you will get an equation in X and Y, and that will be the equation for the perpendicular bisector of AB. So PA, now we will be using the distance formula. PA is equal to, so you have to write any point on the perpendicular bisector is equidistant from the end points of the line segment. You don't have to prove all these things. This is just for your understanding. I explained. You can simply write this, and therefore PA equal to PB, and then use the distance formula. So using distance formula, PA is equal to root of x minus 3 the whole squared x minus 3 the whole squared plus y minus 6 the whole squared is equal to root of, now PB is x minus 3 will become plus 3 the whole squared plus y minus 4 the whole squared. Now squaring on both sides, this root will can be removed, so it becomes x minus 3 the whole squared plus y minus 6 the whole squared is equal to x plus 3 the whole squared plus y minus 4 the whole squared. Now you have to expand it and simplify. Now your x squared and y squared will get cancelled on both sides. So now bring the x and y on the same side. So minus 6x, then minus 12y, and this will become plus 8y. Now bring all the constants to one side. So 16 plus 9, then 36 plus 9, 45. So minus 45. So you get this as minus 12x minus 4y equal to minus 20. So you will get this as, now divide throughout by 4. So minus 4. So you get it as 3x plus y equal to 5. So now this is the equation of the perpendicular bisector of this line. Now we have to find the value or the point of intersection of this perpendicular bisector on the x-axis. So the line, so on x-axis, y coordinate is 0. So we can write this as 3x plus y, 3x plus y, y coordinate is 0, so 3x plus 0 equal to 5. That is substituting y equal to 0 in the equation. So from this you will get x is equal to 5 by 3. So the coordinates are the coordinates on x-axis. So x coordinate is 5 by 3 and y coordinate is 0. Now on y-axis, that is when the perpendicular bisector meets the y-axis, we have to find the point of intersection of the perpendicular bisector with the y-axis. So on y-axis, the x coordinate becomes 0. So substituting x is equal to 0. So 3x plus the equation, 3 into 0 plus y equal to 5. That is substituting x is equal to 0 in the equation. So from this you get y equal to 5. This is 0, so y is equal to 5. So the coordinate on y-axis is, the x coordinate is 0 and the y coordinate is 5. Hope you are clear with this concept. Now this question is similar to the concept that we used in the previous problem. So there we found the equation and then found the point of intersection of this line with the x-axis. Here find a point on x-axis which is equidistant from this. So straight away we are finding the value. So we can write on x-axis the y coordinate is 0. So the point on x-axis is of the form, the point on x-axis is of the form, on x-axis y equal to 0. So it is x 0. Let P be a point. So here let P be a point on the which is equidistant from A and B. Let P be a point equidistant from A and B. Therefore, PA is equal to PB. So now we will, so the point P is x0. So here it is P is x0, A is 2 minus 5 and B is minus 2, 9. This is x0, A and B. A is 2 minus 5 and B is minus 2, 9. So we will find PA is equal to PB. So there is, and we will square PA equal to PB. PA squared is equal to PB squared. So we will remove the root and straight away write x minus 2 the whole squared plus 0 minus minus 5 the whole squared is equal to x minus minus 2 the whole squared plus 0 minus 9 the whole squared. So this will become 25 x squared plus plus 81. So x squared will get cut, will get cancelled. So 4x and this will come here, minus 4x, minus 8x now, 29. So this is 85. 4 and 4 also will get cancelled. So you are left with 81 minus 25. So x is equal to 56 by minus 8. It is equal to minus 7. So the point is minus 7, 0. The same concept we will be using it here. So it is on the y axis. So on y axis, this is the point AB, A65, minus 4, 3. And on y axis, x coordinate is 0. So 0, y. The same, the point on y axis is 0, y. And so the point P, so this will be point, so point P is 0, y. A is 6, 5. And B is minus 4, 3. So P is the point equidistant from A and B. So PA squared is equal to PB squared. So root of 0 minus 6 the whole, sorry, you can remove the root. 0 minus 6 the whole squared plus y minus 5 the whole squared is equal to 0 minus minus 4 the whole squared plus y minus 3 the whole squared. So if you simplify this, you will get the value of y is equal to 9. So the required point is, please do it and see whether you get the value as 9. So the required point is 0, 9. So here in this question it is given, it's an equilateral triangle. So immediately you should understand that it is AC is equal to BC is equal to AB. Now the coordinates of A and B are given. Now you have to find the coordinates of the third vertex. So if you see, if it is minus 4, 0 and 4, 0, then it will be on the x axis, because the y coordinate is 0, it is on the x axis. Now we will let's put this vertex as x and y. AC equal to BC. So AC is equal to BC. Use the distance formula. So you can write this as, I'll remove the bracket and write so x minus minus 4 is x plus 4 the whole squared plus y minus 0 the whole squared is equal to x minus 4 the whole squared plus y minus 0 the whole squared. So this is x squared plus 16 plus y squared. Now here x squared and y squared will get cancelled, and then 16 also get cancelled. So it is 8x is equal to minus 8x, so that becomes 8x plus 8x is equal to 0. So 16x is equal to 0 implies x is equal to 0. So you have got the x coordinate. Now we have to find the y coordinate. For that, let us take AC equal to AB. Either you can take AC equal to AB or BC equal to AB. So here I am taking AC is equal to AB. So AC squared again will be x plus 4 the whole squared plus y squared, y minus 0 the whole squared. So y squared is equal to here minus 4 the whole squared plus 0 minus 0 the whole squared. So this is minus 8, so 64, that's it. Yes. Oh my God. We have to find AC squared is equal, yeah, fine. So this is 64. So this is x squared plus y squared plus 8x is equal to 64 minus 1648. Now we will substitute x is equal to 0. We have already found x, the coordinate of x as 0. Substituting x is equal to 0, you will get this becomes 0, y squared is equal to 48. So from this y is equal to plus or minus 6, this is equal to 16 into 3. 16 into 3. So root 16 into 3 becomes plus or minus 4 root 3. So now you have two coordinates for y. So we will write the vertices are 0 4 root 3 or 0 minus 4 root 3. So if 0 4 root 3 means it will be here 0 minus 4 root 3 will be, the triangle can be like this also. So this will be 0 4 root 3 and this will be 0 minus 4 root 3. That's why you got two values for y. So in both the cases this distance will be same only. Hope you understood this concept. See you with more problems in my next video. Bye for now.